Hello everyone. Today we will be continuing our discussion of scheduling problems with what is known as the decreasing time algorithm. Now, the decreasing time algorithm is basically just a method for priority list scheduling where we make our priority list by essentially prioritizing the tasks that have the longer processing times or the ones that take the longest to complete, basically. So when we're making our priority list with this method, what we're going to do is we're going to look at our project diagram and we're going to start by listing whichever tasks take the longest to complete. So in this case, B and F are the two that have the longest processing times at 5. So those are going to be the first two tasks on our priority list. The next longest ones that we see on here are 4 for D and E. So we're going to list those next. And then next after that, we have C at 3. And then finally A and G with 2. So when we're making a schedule with this priority list, we're going to follow pretty much the same procedure that we did for scheduling with our alphabetical priority list in the last video. So we're going to start by seeing which tasks are ready from the get-go. So in this case, that would be A, B, and C, which only have the start precedent to them. So we're going to circle those to indicate that they are ready for us to work on. Now, we're going to assign these to processors in the order of priority. So B is the first thing on our priority list, so we're going to assign it to P1. And then the next thing is F, but that's not ready yet. We need to have E and D done before we can start on F. So the next thing that's ready is C. So we're going to assign C to processor P2. And we're going to put little slashes through them to indicate that we've started working on them. So if we look at our schedule down here, the next thing that happens is we're going to finish C. So once we finish C, the thing that comes after C in this case is D, but notice that D is still not ready when we finish C because B needs to be done. So the next thing that we have that's ready is actually going to be A. So we are going to do A next. And then if we look at our schedule, the next thing that happens is A and B finish up at the same time. So once we finish these two, that's going to open up both D and E. And as it turns out, we have 2 processors available. And conveniently, we have 2 available tasks, D and E, so we're going to do these next. So let's just give D to P1 and E to P2. All right. Next thing that happens, we finish up D and E at the same time. Notice at time 9 hours. So once we finish D and E, that opens up both F and G. So these tasks are ready now. And we have 2 tasks that are available, and we have 2 processors that are available. So we're going to give task F to P1, and we're going to give G to P2. So at this point, we've covered all of the different tasks. So notice once again that the last 3 hours for P2 is going to be idle while F is being worked on by P1. So this gives us a finishing time of 14. So as it turns out in this case, the decreasing time algorithm actually does not give us any better of a schedule than the simple alphabetical priority list did. The decreasing time algorithm is very convenient and very easy to use, but it doesn't always give us the best results necessarily. In the next video, we will talk about the critical path algorithm, which, as far as scheduling algorithms go, typically is going to give us pretty good results. Thank you for watching, and I'm happy to help with questions as always.